In our last lesson, we learned about Boolean expressions as the condition of an if statement, and we've now also seen them in a while loop. But what if you want to combine together more than one Boolean expression? So what if you want to have something dependent on two variables instead of just one? That's where we're going to use logical operators. So let's go over the three different logical operators. We have logical AND, which looks like two ampersands. Oh, that one did not come out well. There we go. Two ampersands. We have logical OR, which is two up and down lines. And we have logical NOT, which is that exclamation point. And we saw that with our Boolean expressions. So what do each of these mean? Logical AND will return true if both statements are true. So when we say one Boolean expression and another Boolean expression, they both have to be true for that whole expression to return true. For logical OR, this one returns true if one statement is true. So only one of the two statements on either side of that OR need to be true. And lastly, logical NOT. This one is easier to think about as just reversing the result. So it returns true if the Boolean expression is false, and it returns false if the Boolean expression was true. So let's do a couple of examples. We're going to start with some variables. We're going to say x is equal to 1 and y is equal to 5. So now let's see a Boolean expression that uses logical operators. See what that would look like. We're going to say x is equal to 1 and y is greater than 4. So the way we look at these and the way we evaluate them is similar to PEMDAS. So there's an order of operations here. And we want to evaluate things inside of the parentheses first. So let's look at x is equivalent to 1. And that's true because x is 1. Now let's look at y is greater than 4. Y is equal to 5, so that one is also true. Now we're going to look at our logical operator. True and true. We just learned that and returns true if both statements are true, so this whole expression returns true. Let's do another one. How about x equals 1 or y is less than 3? So x is equals to 1, that one comes out to true. Y is less than 3, y is 5, so that one is actually false. And then now that we've done those two, we're going to look at the logical operator. True or false returns true for the whole expression, because logical OR only needs one of the statements to be true for the whole expression to return true. Okay. Now, let's make some space. And this one's going to be a little bit trickier. Let's do not x is greater than 2 and y is equal to 5. So we always want to evaluate what's inside the parentheses first. So let's do x is greater than 2. X is greater than 2 is false because x is 1. But now we need to reverse the result because that's a logical NOT. So then this is now true. Now let's look at the other side. we have y is equals to 5. That guy is true. So now if we do true and true, that is going to return true. And one more, let's do x greater than 3 or not y greater than 3. So x greater than 3 is false because x is 1, and y greater than 3 is true because y is 5, but then we have to do the not of true, which is false. Now false or false returns false because neither of those statements are true, so the whole expression is still false. So logical operators are really helpful because they allow us to have multiple variables involved in our conditions. Multiple Boolean expressions, not necessarily just variables involved in our conditions of our while loops and if statements. In the last lesson, we learned about if statements, where you can execute a block of code depending on whether or not a certain condition is true. But what if you want to keep executing a certain set of instructions over and over again until a condition is no longer true? Well, that would be a while loop. So let's look at the structure of a while loop. We're going to have the start of that, which is the while. We still need a condition, so how about we just say while x is less than or equal to 3. And then we're going to do something over and over again. So while x is less than 3, do something over and over again. So let's define x, because we need to do that first. So let's set x equal to 0. So we set x equal to 0 first, then we ask, while x is less than 3, and it is because x is 0, do this thing. But if we stopped right here, this code would run over and over and over and over and over and over and over again because x is still 0. So we checked it, we did the thing, and then in a while loop, after you get to the end, you just return to the top again. So now we're going to check, is x less than 3? And it is, because it's 0. So we're going to do something. We go back to the top, x is still 0, we do something, and we repeat. So to fix that, we're going to add another line. And we're going to say x is now equal to x plus 1. So now let's go through this loop. X is equal to 0. X is less than 3, so we do this thing, and then we increment x. So now x is equal to 1. We return to the top. X is now 1, which is less than 3. We do our thing, we increment 1. X is now 2. We go to the top. X is now 2. We do our thing, we increment x. X is now 3. We go to the top. And x, let's get a little busy. 3 is still less than 3, so we do our thing again. We increment x. X equals to 4, so we go back to the top. And now 4 is no longer less than 3, so we don't do our thing, and we don't increment x, and we just go to whatever is next in our program. All right, now we're going to go ahead and make a while loop in VIPLE. So for that, if we remember the structure of how the while loop went, we have something like an initialized variable, so like x equals 1. We have the while, and then some condition. Then we have some stuff we want to do in our while loop, and then it ends. at the end of while. So that's what we need to make in VIPLE. So let's go ahead and start with initializing a variable to be 1. So we'll need a data box with 1, and we're going to connect that to a variable. Connect that to a variable. Now let's make our new variable. We're going to call it x. We're going to add it, and x is going to be an integer. So we're going to hit OK. And now we have our variable x. Now for our while loop, we go ahead and we grab a while activity, and we can add that. And then we want to go ahead and say state.x. And this is where we put our condition. So we're going to do while x is less than or equal to 5. So while x is less than or equal to 5, then we want to do some other things. So let's go ahead and print out the value of x at every point in our while loop. So every time we go through this while loop, we'll see x change. So now let's do, for the inside of our while loop, we're going to calculate, and we're going to do the sentence x is, do a space for room for it, and then we're going to print out. So this is the sentence we want to print out. We're going to say x is, and then we're going to print out the contents of the variable, which is x. And we're going to go ahead and print that out just to our normal output window. Okay, so now we can connect these. And now we need to make it so that we don't stay in our while loop forever. Something I kind of forgot to add up here is we need to do x equals x plus 1. And that way we can go through our while loop and not just get stuck there forever. So now let's increment x. So we need to do another calculate. We're going to connect these. I'm going to say state.x plus 1. And then we're going to connect that to x. Okay, so here are now all of the contents of our while loop. The contents of the while loop all need to be connected so that VIPLE knows that it's all part of the same while loop. And then to increment x, we calculated x and then put it into the variable. Or we calculated x plus 1 and put it into that variable. So now that this is everything we want in our while loop, we're going to end our while loop with an end while box, and we're going to connect those. So now the while loop is totally done. But I want to go ahead and add one more thing. I want to go ahead and say that after our while loop is completed, I want to print out help. When we see our program run, I'm going to hope that that helps make some sense. So now that this is all of our while loop, let's run it and see what happens, and then we can talk about what's going on. Okay, so we're going to go ahead and follow this. We've initialized x to be 1, and then now we're starting at our while loop, and we say, well, x is less than 5. Do this stuff in here. So we printed out the value of x, and that's that first line right here, x is 1. And then we incremented x by 1, and then we ended the while. And then notice how instead of going to this block right here, the while loop goes back up to the top. So we ended the while, but we jumped back up here before continuing on with the rest of our code, because our while loop continues going around and around until a condition is no longer met. So at this point, after this first time, when we've ended the while loop here, x is now equal to 2. So then we go up here, and x is equal to 2, so we have 2 less than 5, so then we print out x, and that's what we see here. And then we increment x, we start over, x is now equal to 3, We print that out where it says x equals 3. We increment x, and so on and so forth. And then on the last iteration, we had x is equal to 5, and we printed that out. And then right here, when we added 1 to x would be equal to 6. So we would end our while, and then we would go back up to the top, and x would be equal to 6. 6 is not less than or equal to 5, so then we would skip over all of these, and then we'd go to the next block after the while loop is finished. And that's when we print out all done.